Hi everyone, welcome again. This is part 2 of the Microsoft Foundry networking videos. And again, I'd like to thank my guest speakers, Gabe and Jacob, for joining me today. Be sure to check out part 1 for product updates from our PG team, Mira Kurup. And we also covered the basic agent end-to-end over there. The goal for this new series again is to refresh the content given the product has evolved over the last few years. So for completeness of the recording, we'll kick off part 2 with AI platform evolution and big picture. Then we'll dive into envisioning, followed by demos. So with that, Gabe, I'd turn it over to you to talk a little bit about how our platform has evolved over the last few years.
Absolutely. Thanks, Nahali. To understand a little bit more where we are today, it helps to know where we came from, right? This product has gone through a few generations, as you can see here. We started out with Azure AI Studio, which then changed names to Azure AI Hub. AI Studio was the first iteration. If you've worked with it, you know it's a resource model under Microsoft Machine Learning Services resource provider. This would have a hub, which is an ML workspace, and under that you'd have projects. These projects are also just ML workspaces with a different type project. The hub was connected to separate resources. So you'd have storage, ACR, Key Vault. If you wanted to bring AI services, you could bring that as well. And with AI Studio, we didn't have any agent capabilities. With AI Hubs, that we did introduce some agent capabilities under with the Assistance API, but that was preview feature, and it's not something that we are currently upgrading or introducing new features to, right? So anything agent related, make sure to use New Foundry. These products worked, but they were complex. There are a lot of resources to manage, multiple endpoints to call, too many SDKs, and it kind of had too much overhead. So to mitigate that, we moved towards Foundry, right? In Microsoft Foundry, classic versus new differentiation comes in with the UI and the APIs that we'll use underneath it. But from AI Hubs to Microsoft or to AI Foundry, we unified the entire experience under a single resource model. This is the Microsoft Cognitive Services. Okay, with that, now we have accounts, and then underneath a Foundry account, you have the projects, okay? So you don't have any additional external resources directly associated with it. All of it is taken care under the hood. You can always, of course, bring in other resources through connections, and we'll cover a little bit more about that later, especially on the networking bits. But basically, we unified that solution, and here is where agents shine, right? In the classic Foundry, we still leverage Assistance API for the agent service. And as of November with Microsoft Foundry, these two, just for things are clear, AI Foundry, Microsoft Foundry is the same resource. The new versus classic differentiation is a UI toggle we'll show you in the through the walkthrough as well. We covered it a little bit on the basic standard setup, but here we'll do that as well. Basically, that is the evolution. New agents use Foundry as that is where all of our investments are going into. It is more reliable, better, everything is here, Okay. So that's kind of how we got to Foundry. Jake, any other thoughts on this evolution?
I think the overall, I guess, methodology has been to simplify the connections, even as we add more and more integrations to things. The hub, for instance, everything was so manual for making the connections to all these different things. But with Foundry, it's really a lot simpler to manage, and especially the new Foundry has so much better observability around everything that's going on. But no, that's the history.
Yep, that's an excellent point. Again, goal is to make integration more seamless and easier to use, right? And I think with Foundry, we've done just that. So today, right, with Foundry, you have the classic versus new. Both of these, this is a toggle in the UI. It is the same resource. The main change is the APIs being used, especially for agent service. One, the classic Foundry, which is uses Project SDK v1, our like before 2.0 release of our agents SDK. These use the assistance API, which is on deprecation path. We don't have new investments for those type of agents. So anything new and latest and greatest will be on the new Foundry with agents v2. Okay, this agents v2 uses responses API, which is a more robust API that OpenAI offers. So that's what we want to use. You'll see that obviously both still support basic, standard agent, network isolation. On the classic Foundry, there are a lot more limitations, and our product direction is going towards new. So if you're new to this, make sure you are using new Foundry. If you have agents in old Foundry, use our migration guides and to migrate these agents to new Foundry, as that will be important. Okay.
Awesome. Thanks, Gabe. Yeah, so kind of picking up where we left off in part one. This is the big picture. So the way we organize the AI Foundry agents is into basic and standard at a very high level. And then basic is what we covered in depth in part one. And the standard is broken down into BYO VNet and then managed VNet. Okay, so Gabe, if you want to go over real quick about the basic agent, and then today's topic, of course, will be a deep dive into standard agent.
Of course. As we talked about, the basic setup is the simplest way to get started, right? All of those, the agent state, conversation history files, vectors are all in a Microsoft managed platform. What we want to cover today, and I think where all of our enterprises would be interested in and going towards, is how do we fully secure these agents? How do we get control of our data? That is through the standard agent setup. So first, standard agent allows you to bring your own VNet, right? So basically the outbound calls from the agent service would be coming from your VNet injected resource. Public network access can be disabled for Foundry, so inbound calls have to come from your private IPs. Additionally, if you're leveraging VNet injection, you need to provide a search, Cosmos, and storage account so that the data for your agent service. So basically your conversation history, files, vector stores are stored in your own resources that you provide, right? The use case here is, again, any enterprise regulated, zero trust, places where you need full control over the network and the data. This is production ready. We can use it in new Foundry, and you do have the ability to deploy this in the UI now, which is a great addition that we've recently had. But obviously, programmatically is always a good choice. You can deploy these via Terraform or Bicep templates, ARM as well, of course. So. In addition to that, you do have a preview feature for Manage VNET as well. So we won't be covering this today, but just a brief overview, right? Same concept. We are protecting your environment with network security, but instead of providing and manage all the network infrastructure for agents, we handle that on our end. So you do a VNet injection on a Microsoft managed network, and you control the traffic for those from the agent service via some outbound rules. So basically, you can add outbound rules allowing access to your storage, allowing access to your search, allowing access to specific public endpoints you'd like to, right? The thing is, right now with managed VNet, we only can deploy it programmatically, right, via our Bicep templates, ARM templates, Terraform templates. And there are some additional limitations. It is still a preview feature. We won't be going too much into it today, but know this is an option, and we are also planning on having this be GA'd in the future, as Mira covered it in our last video.
Awesome. Yeah, and it's preview, and be sure to check out the regions if you are testing it. Anything else, Jacob? I have a note here, and I meant to check with you, but is the MCP tools not supported in this managed VNet? Is that accurate, or?
That's a great question. Actually, I don't think it is. You know, Gabe?
Yeah, no, not at the moment. Again, GA is our standard agent with Bring Your Own VNet. That's where we have that support for MCP as well. Managed VNet doesn't have the capability yet, but again, those are investments that are being made. So.
Perfect. All right, so that's a good big picture right there. And the last thing that I want to cover, Gabe, is, you helped me understand this a lot better, so maybe we share that insight about the capability host and the different types. And then I also have a decision tree here. If you want to just talk through it a little bit, I think that would help our viewers.
Absolutely. I think this is one of the more difficult concepts that our users tend to have difficulty with, right? Basically, how the VNet injection and bring your own resources for the standard agent works is via the capability hosts, right? So the standard agent does not exist without this. When you are creating when you're creating a Foundry account, after it is created, you have the ability to add capability hosts, which these are the ARM resources that tell the agent service and Foundry what to connect to. Okay. So big picture, you have two types of capability hosts. Okay. account capability host and project capability host. Account capability host, as the name implies, covers the full Foundry resource. So any project that is created underneath that account will have those properties. A project capability host is specific to the individual project, right? So let's say you create project A, you create a project capability host for that project A. If you create a new project B, you'd have to then create an additional project capability host if you also need that project to have those agents with your own data or with data in your own subscription in your own resources, right? Or you want to use that standard agent at all. How the flow of the deployment works, and you'll see this a little bit as well when we're doing the deployment, is that account capability hosts in general, we're not necessarily making direct API call to create it, right, as the user. You'll see a lot of our templates, including the ones you'll see today. We pass that property of VNET injection in the Foundry property itself, and seeing that it does have VNET injection there, it will then create the account capability host, okay? Some of the properties that are required for the account capability host is first the capability host kind. Right now, we only have agents, so that would have to be set to agents. And then for customer subnet, that is the subnet that would be used for the VNet injection of your agent service. Okay, the subnet needs to be delegated. Otherwise, it won't work, right? You'll run into issues with the deployment there, but it is important that if you are looking to do any sort of private agent setup, you will need an account capability host and a project capability host, okay? You'll see under the account capability host, there are other connections as well that you can add. These are connections created on the, that will be leveraged for other projects as well. These are just connections. They don't actually they don't tell the agent service in the project to use these connections. They're just an additional connection if you want to leverage it for other things. So for example, if there is a search resource, right, that you want to use for additional projects. Let's say you have an index in that search resource and you want to leverage that tool. You can just add that connection on the vector store connection. It will create it, and then all the other projects will also have that connection. Now, when it comes to project capability hosts, this is very important as it tells the agent service what to use for your thread storage. Well, no longer it's still thread storage, but it is the conversation history, right? The vectors for your search, and then any additional files you want to upload to storage. It is required when you're doing any sort of standard agent and you want to do VNet injection that you create the project capability host with those resources there. Okay, so you'd have to pass the storage in the storage connections, vector storage connections, you have to pass your search, and in this thread storage connection, you have to pass your Cosmos DB. Okay, this is per project, so you create it once for one project. If you want to create 2, 3, 4 additional projects in your Foundry account, you would also have to create project capability hosts for those. You can leverage the same resource for the additional projects as well. So that is an option. It just depends on your use case. One additional thing that you can bring is an AI services connection, right? So you can pass a if you're trying to use external models, right, you can pass an AI services connection here. It is optional. You don't have to. Note that with the V2 SDK and new Foundry, that is still under development, so you won't be able to leverage this yet, but this is a feature that is coming. Okay. At the bottom, you see a little bit of the decision tree, right? Basic agent, no capability host, we manage everything. If you want that compliance, data sovereignty, private networking, you then use a standard agent. Yeah. Any
Awesome.
questions?
Oh, this is good. So just it's only applicable again for standard agent, right?
Mm-hmm.
So anything else with the capability host before we go into the envisioning part?
Yeah, one quick comment. Gabe very nicely laid out the distinction between the capability host, which tells the agent or project where to store service artifacts like threads, and connections to tool resources like an Azure AI search index that you're trying to let your agent search over. I wanted to just reinforce with that distinction that when we get into the private networking piece of this, especially private MCP, which a lot of people are interested in order to connect to a tool resource or a private MCP server or something like that that's private through a private endpoint or a virtual network, that does require that the Foundry resource be set up with a standard environment with private networking as well. So even if you are thinking maybe you just need data access to be restricted and on private networks, but maybe not Foundry, the whole thing has to go together with the way that this is set up.
Yeah,
I
there's
mentioned that is
no.
after a couple of incidences of that happening with some of our customers.
Yeah, I think it's important to understand that if you have a private resource that you're trying to bring in as a tool and you're trying to connect to it, our service will not be able to access it if it's public, right? That is a network concept 101, right? So for that to work, you would need to deploy the standard agent, go through setting this up so that the agent calls are now in your VNet and can access that private resource to make the tool calls that you need to do.
Perfect. Yeah, great call outs. I think we will demo that. We'll show it in action and a little bit later in the video as well.
Mm-hmm.
All right, so let's dive into the envisioning part. So if you've been following along with us, this was the basic agent that we covered in part 1, and I have a new tab for the standard agent. So our usual starting point is a classic hub and spoke architecture, the top being Azure, the bottom two being a site-to-site connected branch and an express route connected branch. And we can also add a point-to-site user here. As a lot of our demos, we will be using a point-to-site VPN. And one more thing, if you are curious how I'm using this in the Draw.io, I do have two extensions. So the Excalibur file that we showed you before, I'm using this extension, and for the Draw.io, I am using this extension. Okay, so that's how I'm able to view it directly in Draw.io. So with that, let's let's bring Foundry here. And again, this is BYO, VNet, and standard agent. So this is the Foundry resource. And then it is all in the user tenant, right? So this Foundry resource is in the user tenant. And then we will add the customer managed resources. So it's the storage, search, and Cosmos. And then we also have the agent, which is in a delegated subnet, as you can see, Microsoft .app/environments. So be sure that that is a delegated subnet. And then the way this is designed to work is that this is VNet injected. So what we will do is we will have a private endpoint subnet where we will project all of the private endpoints for all of these different resources. And then anytime you have private endpoints, of course, there will be private DNS, corresponding private DNS zones. And then the most important part of about this setup is that you no longer have public access. So public network access is disabled. So here you will notice that you only have access to it privately using this flow. So the branch user will use either the site to site or the express route or point to site to connect to this private endpoint to launch the portal, and you will no longer have access to it from the public internet. So public network access is disabled. So these are the flows. So this is the inbound flow. So let me hide that one. The other flows are from the VNet injected container or VNet injected agent. You can also hit these private endpoints, and then you could also go out to the internet using either a firewall or a NAT gateway. In this scenario, I'm showing default route 00 via the firewall, and so you can egress through the firewall. You get all of the goodness of private networking if this is VNet injected, and then if the customer has their own PaaS services, you can project that private endpoint over here as well. And then the flows would work something like this. You can create a connection, MCP connection over here. So anything else, any other flows, Gabe, that I missed? Let me light up all the flows.
No, I think it looks good. Some of the important ones would be the agent subnet out to those bring your own resources, right? The thread storage and
The
others that we
orange
talk
one.
about. Correct. Yep, it's important to call that out. It is also the same flow, most likely, that you'd have for any external tools that you want to use, right? It doesn't mean you have to use that same private endpoint subnet, but if you have a search resource in different subnet or a different VNet, if they're peered, that would also be applicable here, right? Yep, I think it looks good.
Okay. So before we go into the demo, I want to call out Gabe has done a fantastic job and has a great repo that we'll be sharing with you that does all of this, provisions all of this. So let me hide the bits and then Gabe, you can tell me if I have it right. So you have a script that provisions all of these resources, including, let me light up your IP schema as well. So do I have this right, Gabe? Does it provision all of this, including the DNS private endpoints and
That
everything?
is correct, right? So how it works is you have a hub spoke architecture where in the hub you deploy that VPN gateway, DNS server, firewall, and we also create a spoke so that your Foundry resources can reside in, right? You'll see on the left side a few of those IPs being used. Obviously, this is all something that can be changed, but the goal is to make these labs as seamless as possible. Really helps with POCs or proof of concepts, making sure that whatever agent end-to-end that you have, right? If it is some form of tool calling or whatever else it is, can be verified and validated uh, in the private network. So yeah.
And you also have the
This
PaaS service, right? I think I missed that. You have this a couple of PaaS services as well, or do you?
mostly I do have a few modules. One of them would be to deploy like a APIM gateway, right? If you want to leverage that. But the main one would be just with Foundry, with those bring your own resources, right? I tend to reuse, if I want to use like search, I tend to reuse that knowledge
I see.
base instead of creating a new search, as especially depending on the region, there can be some capacity constraints and quota constraints there too. So I try to keep it deploying less services if possible, but that's just on my personal labs, right? Obviously, if you have those additional resources, you can always bring them in.
Yeah, and what I liked about it, Gabe, when you first showed me, is that it separates out the infrastructure components. So including the point to site VPN, which is very useful, especially if you want to get the DNS bits right. So I like how you separate out the infrastructure from all the Foundry components, and we'll show that in your repo as well. But
Sounds good. Perhaps we can do a quick kickoff and then go through the portal as it's running so that
perfect.
you're
Let's
efficient.
do. Yeah, let's do it that way. So I think I do have your repo. We can clone it. Do you want to spend just a few minutes just to go over how you have structured this?
Absolutely. First, obviously, read me here. We'll have all the instructions for how to leverage it. Okay, we will go through them. But basically, the launcher will take care of basically everything for you. Just make sure you have some prerequisites. Obviously, it's a Python script, so make sure you have Python. Git, if you haven't used it, to clone it. The OpenSSL CLI, the launcher, if it does not detect that you have it installed, will install it for you. Same thing with Terraform. So basically, I just have a Python file that runs Terraform files and scripts for us, okay? When you open the menu, you'll see a little bit lower that there are a few options, right? You can create, destroy anything you need using it. When you deploy, it is going to deploy the hub-spoke architecture, right? You will have options to select region, select if you want to deploy with firewall or not, and then as that goes through, it will deploy the hub-spoke Terraform code. So if you go back to the top, you'll see there are a few folders there, right? That hub-spoke network, if you click on it, you'll see it contains basically all of the Terraform code as well as some of the DNS server install and VPN installs. Again, just trying to make it as seamless as possible. You do have the option to install the VPN client yourself separately, right? So we give some control to you. But basically, this code deploys the infrastructure for it, right? It creates that hub spoke, it creates the VPN, DNS, firewall. It creates the virtual network, the private DNS zones, and etc. Once that is done, you then have the option to select what is the type of Foundry you want to create. The Foundry itself is the same, but I have two options, right? Which is just a standard Foundry. The other one was with a BIM. I plan on expanding this to some other deployments as well, but at the moment these are the two that I have. Basically, if you go to the BYO VNET folder, that would also just basically cover just a standard agent setup, right? It creates the Foundry, search, Cosmos, storage in your resource, and then it also creates all those private endpoints using the Spoke virtual network on the previous from the previous deployment, right? Same thing with APIM, except that one we also add the APIM deployment as well. We won't be going over this one today, but just know that it is an option if you
Maybe
want to
part
leverage it.
maybe part 3.
Yeah,
Okay.
yeah,
No, good
Awesome.
stuff. No, this is really very useful, Gabe. Thanks for putting all of this work here.
of course. So yeah, if we go back to the main page, you'll see a little bit more of how that works, and we can start cloning it.
All right. So should I go ahead and clone it then?
Sure. Let's do
Okay.
it.
All right. So I have a folder ready here. There's nothing in it, so we'll just do git clone. And there we have it. And then we go to agents. And that's our directory.
Perfect. If here, you should be able to just do, if you have Python installed, you can just do Python.
So we'll create the environment right in this folder, right?
Yes, yeah. Create a virtual
Okay.
environment. Great, and then we can just activate it. See that is very simple. There are no additional requirement files needed. We use basically everything that comes natively with Python. So you can just
Perfect.
run the launcher.py. So let's launch it. Great. You'll see that it will run the prerequisites for you to make sure that you have everything installed. You see that it checks OpenSSL, CLI if you're logged in or not. You see what the user authenticated to and making sure that we have Terraform with the correct versions installed. Here, there are a few options. Obviously, since we don't have anything created, we can't destroy anything. So all we can do is deploy or exit. If you click on deploy, you will be prompted some information. Here, we would want to grab the subscription, Nahali, that you're using. Perfect. Here, we'd pass a region. Again, you note the notes there. I could do like West US 3 or something like that. Generally should be good. There are some limitations as well with what regions agent service supports here due to limitations with responses API. So this is something that validation would do if you insert a region that will not work. So we know West US 3 is good, so you can select that. And then here, if you want to deploy a firewall with it, you can just choose to. If you don't need a firewall for your own labs, you don't have to. Here, we'll do that, and we can show a little bit of that egress traffic from the agent service. Cool. So you see deployment configuration, all good. You should just click yes, and it will begin. Cool. If we go back to the GitHub.
Sure.
And go to Hub-Spoke Network. Under code, there's a variables.tf. You'll see if you scroll down, right, here's the validation code, but here are all the IPs that we have set for the VNet, gateway, subnet, etc. If you ever want to change this, these are the default values. You can do it here. There is a terraform.tfrs example provided on the left side of if you want to modify these configurations, you can create your own TFRs file and modify them, right? But um, again, these are mostly labs, so feel free to do as you wish. You would have to just make sure to add a new um, file here and modify these, or you can modify it directly um, on the variables. If you change the default to something else, it would then leverage that IP instead. Just be careful. Make sure that if you're modifying, it makes sense, right? If I put a CIDR range that for the VNet and the subnet range would not fall within it, it would obviously fail. So just keep that in mind. Okay.
Awesome. No, this is good. Let's take a quick look. I know it's going to take a little bit longer. So two things I wanted to call out. First time I did it, making sure like all of the prerequisites are met, and then making sure that you're authenticated to Azure where you are running it. Okay, so those were the, other than that, I think it will just do everything. Maybe we can take a quick peek at the resource group that it has created. This is the one.
Yes, Hub Spoke. So that is there will be RGA Foundry Hub Spoke with a unique ID. You can see that it started deploying all those resources already. You see your virtual network, some of the private DNS zones started getting created. So this is where you see everything. Later, you'll also see when we deploy the Foundry, an additional resource group will be created, which will contain your Foundry resources and the ones used for the standard agent as well.
Perfect. Yeah. So the experience is that at the first time it will deploy all of this. And then once it's finished, it will prompt you whether you want to deploy this. Okay.
Yeah.
Good stuff. So should we show the portal experience just to, because it's a new feature, how it looks and how we can deploy?
Yeah, let's do it.
Okay. So let's go to Foundry here. So this is NNAI Foundry 66 from our previous demo. It is deployed in the public as a basic agent. So now let's do one with the private networking. So here I have a resource group already created. So let's put, and it's invest US 3. And let's call this all right. So this is where Gabe, if you want to go over the newer features.
Absolutely. Here, this is where we would be able to kind of begin bringing your own resources for the capability host and creating that standard agent. You'll see here the agent service section. Here you are able to select some additional resources. So if you select those resources, you'll see a new pop-up with Cosmos, search, and storage account. Those three are the ones that are required, right? You can obviously bring any existing Cosmos that you may already have, right? Otherwise, we can create new. Note that if you're creating new, obviously these resources will be created publicly. There won't be any private endpoints. So if you have any sort of policies that block creation of public resources, it is best to create the resource externally first, then pass that existing resource here. Okay, so once we add these, also obviously Foundry Azure OpenAI is the AI service connection. That is optional. You don't have to do it. Okay, so once you select those three, this is what is important for the project capability host. Without a project capability host, VNet injection won't matter. As a matter of fact, without creating this agent service part here, you won't even have the option to do the VNet injection. So if we go to the next page, you'll see that the network controls are set here. If you select disabled, at the bottom, you should see an option for outbound access. Outbound access is what we're referring to is outbound access from the agent service, right? You can select the enable network injection to secure that agent service egress. Here, you'd select VNets, subnets that you want to use, right? So for our case, we won't go through and select since we're already deploying this programmatically, but here you'd be able to select the VNet, select the delegated subnet for the agent service, and then once you review and create, it would handle that full creation for you. So it would create Foundry, you'd create the account capability host with the VNet injection property, you'd create the project capability host with those thread connections as well. Okay.
Awesome. Yeah, so just wanted to call out one thing over here, that this is the outbound access. So kind of jumping into our drawing board. This is because this is VNet integrated, right? So this is where we're going to define this VNet and this subnet. Okay, so and be sure that that has the delegation. The good thing with Gabe's script is that it does it all for you. But if you are doing it through the portal, which is the new experience, you do want to make sure. So that's this outbound, and I want to call out this one, and this is for if this is for inbound.
Correct. So this experience was there before. This is just a private endpoint creation for any calls to the Foundry service itself. This wouldn't cover outbound agent service calls, right? But obviously, Foundry, you can secure it as well. Disable public access, create a private endpoint so that users and anything within your network can access this resource. Script also handles that, right? We create those private endpoints for the Foundry service, not only Foundry service, but for the additional resources as well. Okay.
Yeah, so these are the private DNS zones for the Foundry service itself.
Correct.
So this private endpoint then, jumping back to the drawing board, is for inbound for this access, right?
That is correct. The private endpoints created there is the inbound for Foundry. So basically it would now allow connections from your users or VMs or whatever to the Foundry resource. This would not be the case for like search, for example, right? At least in that flow. If
Yes.
you if you create a search via the portal outside of the Foundry portal experience, obviously you can create the private endpoints for that search there. Does that make sense?
Yes, so just to recap what you just said, Gabe, is that all of these resources that we created, if we create through the portal experience, they will all be public.
Correct, right? That's standard generally if you're creating new in these experiences. So if you do have any restrictions with creation of resources that are public, just create them on your own first, or leverage some of our samples that already deploy these resources privately for you.
But if you have an existing one with private endpoint enable, you could use that here. Would it show up? It would show up in the drop down here.
Correct. Yes.
Okay. Let's take a quick peek at how our script is doing. Looks like it's going.
Let's go to some of the failed deployments that you had, Nahali. We can kind of go over it a little bit.
Yeah, good point.
Love
Yeah,
that.
so sorry.
Oh no, I just love that. Gotta look at how it
Yeah.
goes wrong too.
Yes. So if you hit review and create over here, sometimes the deployments will fail, and we'll show you a couple of scenarios where we've seen the deployments fail. So good point, Gabe. I do have it in my troubleshooting layer, so let me make it a little bit bigger so you can see if you want to go over this one.
Yeah, let's look at the first one. So this is very common error for users that are deploying this for the first time. You'll see that this was triggered through the UI. Correct me if I'm wrong, Nahali.
Yes.
Yeah, so you'll see that it's creating the storage, the Cosmos search, etc. And then it goes and tries to create that account capability host. Account capability host is what has the VNET injection information. Notice that on the error here, the failure happened because not all of the app registrations for the resource providers were done. So it's very important that if you're going to use this, make sure you register all of the required resource providers. The full list is in the Foundry Samples GitHub that we'll have here in the description. Okay. But this is very important, otherwise you will just continue to see failures. Okay. If you leverage the launcher, when we get to the Foundry deployment, we validate that these are first registered. If they're not, we'll register them for you so that you don't run into issues with the deployment. Okay.
Yeah, good call out. When I saw the launcher, I was quite impressed that you had that covered very nicely. So if you don't have it registered, it won't even deploy, as opposed to failing at the end, right? So
Some
that's quite nice.
validation is generally
Yeah.
better than
Yeah.
yeah. Another one here, similar error, again, when it comes to capability host deployment. Unfortunately, the error message is not as clear, but from my eyes, I've seen this a few times, right? When I see it put to Central US, I know that that region is not a supported region for the agent service, right? This is one of the limitations I was talking about with the responses API. So that's another thing to make sure that if you're going to leverage the agent service privately, if you try to deploy these in one of the unsupported regions, you may run into this error. Again, the script has validation for this, and the Foundry samples that we will have in the description will have all the list of supported regions. Okay, so just make sure that these steps are done. Otherwise, you may run into some of these failures.
Awesome. Good stuff. So let's take a quick peek. We'll pause the video. Is there anything else?
Since you're running this on PowerShell, we won't be able to see the logs generated in real time. So I guess we can do that later. Or if you want to open it in VS Code, I can walk through that as well.
Sure, let me open this in VS Code. Under logs.
Yeah, so here if you click on logs, if you ever need to troubleshoot any failures, if you run into any issues, obviously feel free to open GitHub issue. But here in the logs, you should see why something may have failed. Right now, it's running, so you won't see too much info, but once it's complete, this will get created. Yeah, any new deployment that is done, you'll see that log pattern with a date as well as time .log. If it is the destroy, it will have a destroy date time .log. Okay, that way you can take a look at what was the failure, why did it fail, is it something with Terraform or anything else. Another thing that I think makes this great and easy to reutilize and redeploy things is that deployment state JSON. So if you go to the left, you see there is, or yeah, on the left right below it, there's a deployment state. You'll see that right now, all of the states are, you have one in progress, right? Because we're doing the hub spoke deployment. But if for whatever reason, let's say you deployed the hub spoke and there was an issue with the VPN client install, right? And you want to run that again. You can just come and change the state from pending, or I mean, you can change this to pending so that when you do the deploy again, it would reattempt that VPN client install. Okay.
Nice.
So this is just something to keep in mind if you're trying to kind of do a little bit of that redeployment. When it comes to the BYO VNet, right? When it comes to Foundry deployment, if it fails, it will set the state to failed, and that will get retried automatically. But some of the smaller things, that is something that you can come and manually change if you'd like to.
Makes sense. All right, so let's take a quick peek and then we'll pause the video. Yeah, I think part of it is the VPN gateway provisioning itself just takes 30 minutes. So we'll pause the video here.
Awesome.
So we paused the recording. Looks like it has progressed nicely, Gabe.
Yeah, we can see here that step one was completed, right? We successfully deployed all the resources for the hub spoke in that resource group. So if you go to your Azure portal, you should see all of your hub resources, right? This would be your hub VNet, firewall, DNS, etc. Yeah, if you refresh, you should see a few more things. Yeah, you'll see firewall, the policy, all DNSGs it creates for those VNets, the private DNS zones. If you go to the second page, you should also see the DNS VM, the VNet gateways, and the hub VNet, and as well as the Foundry spoke VNet. Okay.
Very nice. So I see a lot of DNS zones. So you also use the key vault.
So some of these are there for future use. So for example, I'm not leveraging Key Vault right now, but if you want to use Foundry and connect to a Key Vault, the zone is already there for this infrastructure, right? It's already linked to the spoken hub, and so it makes it easier if you do want to bring in the additional external resource, right? Same thing with like a table this is a storage account one. I don't explicitly create the private endpoint for it, but if you do have something there that you want to leverage, you can create the private endpoint on your own end. Does that make sense?
Yeah. So the ones that are important for
Yes, the main ones are blob.core. This is for your storage, resource, cognitive services.
oops.
Obviously, that is one of the endpoints for Foundry. You would have documents.azure.com, that is for your Cosmos DB. File.core is file endpoint for the storage. We don't use it right now, but that is something you may want to leverage. Notebooks is AML. We're not using this right now. If you go to the second one, OpenAI, that is another endpoint that Foundry leverages. Q is an additional storage endpoint if you want to leverage. Search is for the search resources. Services.ai is another Foundry endpoint that we leverage. This one is used for agents. Inbound calls. Table is another storage one if you want to leverage, and then same thing with Vault Core. So the main ones for the default basic Foundry deployment would be you can see here under DNS, these would be the ones that are used and required for the standard agent service.
Perfect. So this is an accurate list of,
Mm-hmm.
Okay, good. And in the meantime, I got prompted, and let me share that screen for the certificate and
Yes.
this screen. So you can see both
Perfect.
the screens here.
Yeah, so you'll see before we started, step one got completed. It was running then the DNS server configuration. What that was doing, it was just creating the conditional forwarders on the custom DNS so that private resolution works for both the VPN and anything within the VNet. The next step is, since we're using point-to-site VPN and this point-to-site uses certs, we are doing a certificate installation. You see here it is deleting a previous certificate that Nal used for this deployment. So here we'll say yes as well. And now we're installing the new certs for this VPN client connection.
The root certificate.
Mm-hmm. Yep. So if you scroll down on your page, you'll see that great, we installed the DNS. Now we successfully installed the VPN certs. And here we are now give you the option to install that VPN client, right? So a few options. If you want to skip it and then just download it manually later, that's completely okay as well. Just depends on what you want to do.
So
For
the
us, we'll
first option, right? The first option creates a line item under your VPN settings, right? Like it just would
correct.
create a new, so maybe we can take a before. So I have something from before.
Mm-hmm.
So it would create something like a new one like this.
Mm-hmm.
Okay, so I'll go ahead and hit one over here, right?
Yep.
And so
Yeah, it tells you as well which VNet or VPN gateway it's using, which resource group it's in. So if you want to validate that on the Azure portal, you can. Okay.
so I got prompted again. Do you
Mm-hmm.
want, so we say yes.
Yes, since we are installing VPN client, you need admin on your local.
Yeah, so it's asking me to install that VPN connection, and hopefully I can share once it's added.
Yeah. Now, great. Yeah, do you want to
So
show the...
yeah, so this is the 169938. So let me just delete this old one so that I don't confuse it. So yeah, so this is ours.
Yep, that is the new. If you want to connect to it, you feel free to do so.
Sure, let's give it a go.
Or we can connect to it later once we deploy everything. Either way. It prompts you at the bottom right. You'll see a little VPN symbol on your taskbar. Yeah.
So I'll just share this.
There you go. And you're connected.
Awesome. Should we run a quick IP config test? So here in the IP config output, yep, we see the VNET hub. The IP is coming from the 172.16, which is the VPN pool, and this is the DNS server. So we can do more NS lookups once everything's provisioned, but the first part looks good, right?
Yeah, that's great. You'll see here on the next step, you have the option to just deploy the infrastructure, or if you want to do Foundry with just VNet or Foundry with APIM. For us, we're using the first option, so we'll select option 1. And with that, we confirm. And we'll begin the deployment. First, I think we mentioned it a little bit before, it's going to make sure that you do have those IPs
Resource
registered.
providers, yeah.
And if you're using the same subscription, we'll store that information so it doesn't run that check every time. I mean, yeah, that's basically it. Once this is done, let's make sure it's all there. Network, Microsoft.app. Yep. Great. So you already have everything registered. If you don't, it will register it for you. And now we're initializing, and we will run the Terraform apply to the form to deploy the Foundry resources.
Awesome. So we'll pause the video here and we'll pick it up when it's done then.
Perfect.
So we paused the recording and Gabe, it looks like it finished, looking good, except a few
Yeah.
failures here.
It looks good. We do see that a little bit out of that retry logic that we have, which is good. The first few applies failed, but the third attempt was successful. If we were to go to the logs, we could also see why those failures happened. Search resource was failing to provision because of some capacity concerns. That's something to keep in mind. There are some regions that that have limited capacity. This is known for search, so just something to consider, which is why we chose WestUS 3. It was eventually successful, but even in that region, we'd had a little bit of that issue. So anyways, the launcher handles it gracefully so that if there are some transient issues, it will retry before completely failing. So we should be able to go to the resource group. You can either on the terminal output, you'll see the portal. You can click on those, or you can go directly to the portal. So
I see. I see.
yeah. Awesome. And you see this is our Hubspoke resource group that we were talking about before. If we go to the other one, it should be the Foundry resource group that just got deployed. Before we review a little bit of this resource group, let's just complete the work on the terminal. If you just hit enter, you'll see the menu will pop up again. You can see that there are a lot of other options, right? Here, you should be able to just, once you're done using this environment, you can just click on 2 and destroy. We can do this right now, Nahali. We won't complete it, obviously, but if you just click option 2, type in option 2, sorry.
Oh, would it destroy or would it prompt us?
It will prompt you, so it won't it won't do it. You can see here the options. If you want to just choose to deploy or destroy Foundry, let's say, great, you did what you needed to do in Foundry here, and you want to now deploy the APIM module, you can destroy here and then continue, and it will prompt you again to choose what you want to deploy. Or if you're done with the environment completely, you can just destroy all and it will handle all of that for you. Okay.
I see. I see. I thought it would, I was afraid to put 2 because I thought it would destroy it. I see.
No, there are a few confirmations. Even if you click 1 here, it will ask you to confirm again. So
okay, good.
yeah. So either way, we can cancel and then exit the program. It will, if you launch it again, it will pick up where it left off, thanks to that state file that we talked about briefly. So again, you.
So right now it should all be completed.
Exactly. Yes. So if at any point, right, once you, let's say you destroyed just the BYO, that will be returned to status pending so that you can basically choose to deploy it again. Okay.
Okay.
Okay. Yeah, we can quit. So this is no longer running and you're good. We can go to the resource group in Foundry and see what is available.
So this is the Foundry resource group, and we have 13 resources here. Should we look at, it's sorted by type, so must be a lot of private endpoints, I think. Yeah. So lots of, yeah.
4 private endpoints, right? 1 for Foundry, and then 3 or 1 for storage, 1 for search, 1 for Cosmos. You'll see the Cosmos resource created at the top, 1 Foundry account, 1 Foundry project. You'll also see storage and search at the bottom, and that is what is created.
Awesome.
For us right now, what we can do is let's connect to the VPN, do some NS lookup validations, and then see anything else we may want to do there.
Okay.
Perfect. Okay. So here you should be able to go to the Foundry private endpoint. It's that first one, yes. And under DNS configuration, we can fetch, let's say that first FQDN. Let's grab the non-private link one. You'll see FQDNs again. Yes. And if you launch, yep, and then do an NS lookup.
I think our VPN is still connected, but let me just double check. Yep,
yes,
it's still connected. Okay.
That's great.
And I'll just do the IP config just for completeness. And we should have over.
Yep, DNS server is 10.0, so that's good. And if you do an NS lookup, you see that it leverages that 10.0.1.4, which is the DNS server. It returns the private IP of that FQDN. You also see under non-authoritative answer, you have a CNAME pointing to the private link FQDN, which is what is being used to properly resolve this to the private IP.
So next, Gabe, should we look at the networking configuration on the AI Foundry?
Yes, let's go to the network configuration. Yeah, here you can see that the firewall virtual networks, we have it set to disabled. It's important that you have those allow trusted services enabled. in contrast to what we had before, where all networks were allowed, right, on the previous video. If we go to private endpoint connections, you will see there's one private endpoint created. This is that inbound PE for Foundry. So any calls from your network to Foundry, since public connections are not allowed, will have to go through this private endpoint. If you go to network injection, you will then also see that one delegated subnet ID is now filled in. It contains that agent's subnet that we previously mentioned. And notice that manage virtual network is disabled since that is not what we're using. If this was enabled, we would see a little bit different here. Let's go to that subnet as well so we can see a little bit of that, what that looks like.
And that's in that hub spoke VNet. And
Yes,
then the
this would
subnet.
be in the spoke VNet specifically. You can see we have a few subnets. First one, private endpoints. In this case, what is being the network injection for Foundry is using that SNet agents that we talked about. If you can see here, it is important that it is delegated, otherwise your Foundry deployment will fail. It will be unable to leverage the subnet. And then notice as well that we have a route table on the right side. This is configured to route all traffic to this 2.4 address. This address is the firewall, okay? So all traffic from the agent subnet is going to the firewall. Okay?
Perfect. Yeah, and we have DNS also set up at the VNet level, right?
Yes, so both the VNets will have a custom DNS server. They're pointing to that 10.0.1.4 in the hub VNet, which is what is being used for the resolution of those private endpoints. The server has a global forwarder to Azure Recursive Resolver, which is that 168 address. Did also create conditional forwarders for the zones just for completeness in case folks want to change that that default forwarder. Okay.
And these DNS zones are all linked here to the,
Yes,
yes,
they need to be linked to the hub where the DNS server is so that it can properly resolve these private endpoints.
perfect. Okay, awesome. So now coming back to the drawing board, what we will do next is we have a jump box here in the VM subnet. So what we'll do is we will access this private endpoint, the one that we just showed you in the networking tab. We will get on this jump box and use this jump box to access Foundry resource. In the real world, you could access it from site to site VPN and express route connected branch, or if you deployed it using Gabe's script, it has all, you can use it using the VPN client. So anything else you want to add before we jump on this subnet?
No, I think that covers it. Just to emphasize, none of the access from public will work in this scenario now, right? Since we have all of that public traffic disabled. So make sure you are leveraging one of these methods, be it VM, VPN, or ExpressRoute to connect to network in Azure so you can access the resource.
Privately. Yeah,
Yes.
perfect. Yeah, so let's hop on to this jump box. So here we are in the jump box, and we will get to this Foundry. Do we want to show that it will fail externally first, maybe?
Yes, let's do that.
Okay, so here we are in the, and we go to Foundry here. This is from my laptop, which is not connected privately. So now it is failing. And then we'll go to the jump box and we'll do the same thing from here. So notice that this tab, let me close a few tabs. So this is the Win jump box, and I am connected using Bastion. So sign in.
Let's sign in.
Should go to build, and there we have it. Should we also validate
Amazing.
it? Yeah, using dev tools. So if this is not working, so you could validate using dev tools. Let's refresh this. So we'll have the network.
Yeah, in the scenario where this is not working, you get that message. You can open DevTools, see what API calls are returning 403, and on the call itself, you may see something like, oh, the DNS resolution is not working, right? Which would lead us to the failure. And like Agents API, yes, perfect. And then you'll see the remote address here is pointing to that 10.1.0.10, which is the AI services FQDN private IP, right? In case of failure, you might see this resolving to a public IP, which would indicate, hey, maybe check your DNS server, or you're not even in an Azure network at all, right? So if we were to do this on the other Foundry we had open, you would see a public address here instead of private, and you know your problem. So
Perfect. Yeah, and for completeness, maybe I'll just show one more thing here, Gabe, that we are indeed on that VM in Azure. And if we NS look up this FQDN, back to the jump box here. This is by the virtue of the DNS and the linking, the VNet linking, that we get this 10.1.0.8. So it's all working privately from this VM in Azure.
perfect.
All right. So next, let's just create a simple agent first using, and we'll copy what we did in our public video. So let me grab the instructions from our public network agent, network assistant agent, and we'll put it here. And we'll save. We don't have any tools attached, but we'll just go ahead and save. And we'll ask some question. Help me. So we'll ask a question. What is the capital of Brazil? It's not supposed to answer this question. Should this trigger logs, Gabe, in the firewall?
Absolutely. Yeah, we should be able to see a lot of network calls from the agent. So if you do want to go to the firewall right now, we can show a little bit of that.
Sure. So we have this firewall tab open and we can close this, but this is the same resource group where we programmatically deployed the firewall, and then we go to the logs and we can say firewall log data.
Perfect.
Run, and we can say last maybe 30 minutes, and here we can see the logs.
You'll see that this IP, the 10.1, should be from the agent subnet. That's the source IP. Yeah, some of these queries are going to the, or some of these requests are going to 20.190, 150.171. These are just generic public IPs. One will be for the AAD service tag, which is where we fetch a token for authentication so that the agent service can run. But yeah, you will see here that all the requests are indeed coming from agent subnets, and not only that, but we are allowing these requests from that subnet as well.
Yeah, so your firewall rules are set up to be allow. So we can
Yes.
take a quick peek at that.
Yes, that would be under overview. And you should see the firewall policy. Our policy under rules will have all of the rule collections. Right now you can see I have two rules allowing all traffic for network rules and application rules. We could be more restrictive with this, of course, right? If you do want to deny traffic to public IPs, we would just need to allow specifically traffic to AAD. That is the requirement for agent service. And then if you want to allow other requests to public, you can do so by adding specific rules on the firewall.
Awesome. Yeah, I love the logging and the visibility on the firewall. Perfect. But should we go to your repo next here?
Yeah, let's do it. We previously created search resource or I mean a search tool via the UI, right? Here I want to also show a quick sample of how to create it programmatically, and then we can leverage this for an agent in your Foundry account. Okay.
Yeah, and this will help us through all of the permissions, and everything will be done programmatically, right?
Exactly. If you start by cloning the repository, we can do that.
Okay, so we'll grab this, clone it. So we did install Git and Python on that VM on the jump host, and we will clone it here, right?
Yes.
Restart this.
Yes, probably. Maybe a path issue as well, but perfect. Okay, awesome. Let's see what we have. And then list again. Perfect. Let's navigate to that first one, the search tool agent. Okay. And if you see here, we have a few things, including the JSON example. What we will have to do first, right? If you open the GitHub and navigate to that search folder, we should have the README instructions on one, setting up the virtual environment, initializing it, and then two, we'll have to grant permissions for your user on search so that we can create the index, and then the rest will be taken care for you. So if you scroll down, you'll see here on the setup, right, how to do this. So you can run that virtual environment to create it, then activate it. So you see those first two commands.
These two? Okay. Right, so let me grab this and then we'll paste it here.
So now that it's activated, let's install the requirements. While this is running, let's also grant your search resource some permissions. You'll see that the requirement, the third one, right? Basically, search service contributor, search index contributor for your user, so that when we run the setup search.py to create the index and your search resource, you have permissions for that. So if we go to Azure, let's navigate to the existing search that we already have. That should be the one. And under access control, so first we can validate. If you click on view my access, we can see if you have it already, which you don't. So we will need to add those data actions, right? So we're going to add role assignment, search for search. Yeah, perfect. Search service contributor. And then add your permission. It's for your user. Yep, perfect. So great, reveal assign. Let's also add that index data contributor. Hmm? All the other permissions were already taken care of during the deployment of Foundry. So that is all we need to do here. If we go back to the terminal, we see that it is now installed. Great. Let's run an AZ login as well, so we are authenticated to Azure. Great. While this is installing, do we want to open config.json as well so that we can edit the properties with your newly created Foundry? Oh, perfect. Okay, sorry, missed that. So if you go to the search tool agent, we have a config.json example.
Okay.
We can open that. Okay, great. All right, here you see there are a few things we will need to change. First, let's get the project resource ID from Foundry. Project endpoint, perfect. And if we go back to Notepad, yeah, the first one, project endpoints. Paste that in. Okay, great. And now we need to grab the project resource ID. Oh yeah, you can go to projects, then click on the project and then go to properties.
Okay, I'm going back to the jump box here.
Paste that in.
Okay. And then search endpoint as well, right?
Yes, let's add the search endpoint. It's the one, you see that URL at the top right? Yep. It needs to be updated. Okay. Perfect. Now here, this next part, this is to create a search connection. Since we already have an existing connection on the Foundry, we can set it to false, and then we'll just update the connection name with the existing search connection that we have. Okay, so it's already set to false. That's good. We will then need to go to the Foundry resource, go to connections, and then grab that name.
I see. Okay,
The name of the connection is going to be AI Foundry unique ID. In this case, it's 3296 search. So if you want to leverage that, that's good. Otherwise, we can just go to the jump box. Let's go to the jump box, go to Foundry. And then under operate, admin, click on the project that we are in. Yes, that first one. And then under connected resources, we will see that search connection, which is AI Foundry 3296 search. Notice that we have 3 other connections as well, which are storage, Cosmos. Here, these were created when we deployed, before deploying the cap host, so that the agent service knows where to store those conversations, indexes, and etc.
I see. So if the customer had their own search, want to leverage their own search, they would have to create that connection.
Yes, if they're using the search sample, they can leverage true for creating a new connection, right? And
Yeah,
then pass the name of the connection and it would create that for you.
got it. Okay.
Great. And then here we just need to update the model as well. Let's deploy a new model and then we can leverage that.
Okay.
So if we go back to build, go to models, deployments, let's deploy a base model. Search for GPT-5. Perhaps we can do like GPT-5.1. If you have,
This one?
yeah, see if you can deploy it. If not, we'll go to like a 5.1 mini. Not sure if you have the quota. Doesn't look like you do. So, yeah, if you see it's grayed out at the top right, which means you don't have
The
sufficient quota
deploy.
for this. So you don't have quota for this model. So let's do a GPT-5.1 mini. Yep, perfect. Config JSON agent model. Now let's save as instead of config.json.example, just config.json. Remove that last dot. Perfect. Okay. Let's save. Perfect. That looks good. Now go back to the terminal. Are we completed? Perfect. Let's do that AZ login.
So what is it? AZ login. Yes, device code. Okay, should we change the folder to
Yes, let's go to that search or agent Foundry networking, Foundry agent samples, 01. Perfect. Okay, now we should have config JSON configured and all of the other ones. What we're going to run, if you go back to the GitHub, should be the search setup. This one is, yes, let's go to the 01. If you go to a little bit lower, you'll see keep going. We configured the things. We now did AZ login. We're now going to run that Python setup search.py. Before running this, let's double check we are in the environment as well, since you changed shells.
Mhm.
If you do Python, perfect. Okay. This will run to create index. You'll see the steps here. And perfect. Now the index is created in your search resource. What we need to do now is create the agent. So we will run Python agent search tool.py. So it fetches the existing connection since you already have it. It is now going to create the agent. Once that is completed, you'll see it tries to run a query. Here in this case, we uploaded some Contoso documents, right? Which has some travel policies and meals and accommodations. And you'll see below, it fetches those responses from the document. And with the citations, since it was a search index, it points to that AI services or AI search with the specific lines. If we now go to the Foundry resource and go to agents, you should be able to see that search tool agent now created. If you click on
Nice.
it, you will also see on the left side, the tool, right? The search tool pointing to that index. You will then also see we have some instructions of what this agent needs to do. Okay. If you want to, here we can send another query to the agent, and we can ask again something about the Contoso documents. Could you ask perhaps like, yeah, we can use the same one or do something like, could you summarize the Contoso documentation in the index or something like that? And here it's giving you a quick summary of each of the documents, and it points you to the 5 documents that are used as well. And so we can go to the logs here as well. And yeah, you can see the search call was done. It fetches the documents, and on the message, you'll see the message with the specific sources. So
Nice.
simple, straightforward. Yeah, cool.
Awesome. So that was all done programmatically. And I'm curious, so did you upload those Contoso documents into the storage?
So how this works, right? When we're creating the index, the files are local. I am not directly uploading them to the storage here.
I see.
If you go to the AI search resource, yeah, you'll need to be on the jump box because I don't think you'll be able to see the index without it being on the network. So, and then yes, click on search management indexes. There it is. This is the index we created. Load these files directly to the storage account first. These were locally and just leverage them.
Got it. Yeah.
To upload them
Awesome.
to the search index.
Awesome. So that was a good demo. And again, this is all done programmatically, and the permissions are and the prerequisites are over here.
Yeah, I was going to say we can run one of the MCP tool samples for Foundry IQ. Foundry IQ also leverages search, but instead of just creating one index, it creates an MCP server against those documents. So if you see on the left side, there's two MCP tools.
Nice. Okay.
And then under it, there's Foundry IQ. Click on the README. That would be perfect. So similar thing, we'll need to do a setup here, updating the config JSON. So if we can do that, we can quickly run this sample as well. Do you want to, on your terminal, navigate to the second folder and then go to Foundry IQ? The main difference is Foundry IQ, or I guess search tool, issues like a single query against the one index created, and we'll ground that answer in return chunks. So it's better for like focused, self-contained questions where answers would be in like one document. For things that span multiple documents, it would be best to use something like Foundry IQ, that it better synthesizes those answers, that information from all those resources. So let's show an example of Foundry IQ as well. That's the direction, at least, our service is going towards. And yeah.
Perfect. So we should be able to grab these things from this config JSON as well, right? They're the
Yes.
same. So
Mostly the same. We will change, well, the search Foundry obviously are not going to change, right? So let's grab those, and then once we get to
so we can grab these three things, right? And then your connection name.
Create search index is true. That's good. We need to create a knowledge base as well. Notice that for Foundry IQ, on top of the search index, we also create a knowledge base, which is what we will point to. Okay. Under knowledge base, we don't need to fill those out. Those would be optional parameters for the search service. And then, yes, in this case, we are going to set this to false because the project connection here is no longer just that search connection. It is actually creating an MCP connection, okay, that points to that search knowledge base, okay? So we can add a name for this connection, whatever you want. I like to call it something simple like Foundry IQ MCP connection. Awesome. Perfect. And there is agent model. Yeah, agent model as well. Copy that one. Perfect. Perfect. So project endpoints there, resource ID, search resource. True, we're creating a new index. Foundry IQ, samples. That looks good. Let's save this as config.json.
So this will create a new index, right?
Yes, we're creating a new index for this. And on top of that, using that index will create a knowledge base on the search resources. Okay. Great. Now we should be okay with the same environment.
So we go in the MCP tools folder, right?
Yes, we'll go into the MCP tools folder, go into Foundry IQ. If you list, you'll see a few things. Obviously, the data is all within that folder. Here, we need to set up that knowledge base. Okay. So you can run Python setup knowledge base.py.
So the instructions are under the Foundry IQ README, right?
Yes. So
And
we can recreate the environment. The requirements should be the same, if I'm not mistaken, as the search one. I will double check. Yeah, so we don't need to create a new one since this is it's the same environment. The requirements is the same, so we can leverage the one that you already have for search, and we
okay,
can just run the setup, right? In this case, what we'll need to do is run Python setup knowledge base. Perfect. Here we'll run create an index, create a knowledge base, and then yeah, that's what this part will do, is just setting up the requirements for Foundry IQ. Fantastic. You can see all of those resources created. And then what we will do is now run the Python agent Foundry IQ.py.
agent.
Yeah, agent. If you just do agent,
Yeah,
you should be able
yeah,
to. Yeah.
yeah.
What is it not finding?
We may have to
Let's see.
connection
Project
name.
connection name. Scroll down. Can we see that config JSON? Maybe.
We missed something.
Yes. Okay, 1 second. So, create search index is true. Oh, okay. You see how the create project connection is set to false on line 29? So instead of trying to create it, it was looking for the connection. Since we don't have this, it will fail. So we should set this to true instead. Save. Perfect. Save. And then let's run it again. It should find the connection successfully this time.
I see. So in this one, we had it set to false.
Yes, on the search one, we had it set to false because the connection that it needs is the search connection. Since we already had it created, we did not need to create a new one. For Foundry IQ, it's an MCP connection. So it's going to create, we're going to need to create a new one. Obviously, if you already have all of these resources created, you don't even need to run the search setup, right? You can just pass the connection that you have and create the agent that way. Okay, so here, similar thing, we get an output. And you can see that verbosity over here tends to be a little bit more detailed since the IQ with MCP Server is going to be better at querying through multiple documents. So if you
Thanks.
have
And
something that requires more, rather than just a focused index, if you need to use query through several documents and get some synthesized answer for this, Foundry IQ is the way to go. That is your answer. If you go to the Foundry right now, you should be able to see that agent there as well if you refresh this page. There it is, Foundry IQ agent.
We have the Foundry IQ agent.
Perfect. And similarly, we can run a query here.
Do you
we
have
can
a
use that
sample
same.
query, or should I run
Yeah,
this
we can
one?
use the same one. We can use a summarize those documents or something like that.
Summarize Foundry IQ documents.
Sure. What happened? So it did.
It did call the MCP
Call the
tool.
MCP. It listed. Okay, let's do a better. Let's do a better targeted thing. Let's do.
Or let's first do this one, which you already have. That should work.
Yeah. One thing to call out is that for the search sample, what I did is I have tool choice enabled so that basically anything that happens, choice, yeah, it should try to query that the tool. So basically we'll leverage the tool for the query, and then if it does contain relevant information, it will produce it. If not, it won't. I think a better question here, instead of summarize Foundry IQ, it would be summarize the Contoso document, since those are the actual related documents, right? We don't have any like Foundry IQ documents. We have the Contoso documents. Those were the uploaded ones. Some okay.
I see we've got some citations there as well.
Yes, these are MCP tool citations. So query that knowledge base. You'll have an answer here. Similarly to search, search also output the citations. So there you go. Yep. As you can see, this will be a better query because it actually points to existing documents. Foundry IQ docs are not a thing in that knowledge base, right? So
makes sense.
That's good. One thing I want to call out as well, if you go to the Operate tab and then Admin, you'll be able to see that we did create, in fact, a new connection. This would be an MCP connection. Under Connected Resources, you see that Foundry IQ MCP connection. You see that the target is search and the specific knowledge base / MCP, since this is a MCP server. Okay.
Very nice. Yeah, that was a great demo, and this is all done through your GitHub repo, right? We didn't have to. Yeah, perfect.
You can follow it along if you want to do it on your own, and obviously if you need to modify or add your own data, the data folder, you can upload any documents you may want to use. Okay.
I see. So in this folder.
Any other comments or questions on this?
No, I like it. I think this is all very relevant and done all programmatically. So great work. I had not tested this before, so this is good.
Yeah, pretty smooth. Ran into so that's good. Always nice to see things work like that. Just got to make sure we follow the prerequisites, right? So cool.
Perfect. Okay, so with that, we are ready to show the last couple of flows. And so going back to the drawing board. So far, what we showed you was through Gabe's repo, you had a programmatic way of creating a connection to the Foundry IQ MCP connection. Next, what we will show you is we'll use the function app that we used in the part 1. And what we will project the function app as a private endpoint in the private endpoint subnet. And then we also have a private MCP server in the same subnet as the VM. So it's local to this container app. And we will connect to the MCP server privately. And if you remember in our previous video, we didn't have this feature, right? Jacob, this feature was not available until recently, MCP and private endpoints.
Yes, that's correct. That's part of the end-to-end network isolation with the new Foundry. So we now do support private MCP servers, which we know is a big ask.
Awesome. Yeah, so we'll demo that next. So we'll start with private MCP server, and then next we'll make this function app private, and we'll demo that. So let's jump on to the VM, this VM where I have the MCP server running. And here we are. So if you see on the screen, I have 4 screens. The 2 left-hand screens are on the Linux-based MCP server, and you can see the IP address of it is 10.1.3.5. So here we have a very simple MCP server. The difference between the one we showed you before and this one is that we've added this SSL certificate, and we have associated it with mcp.penguintrails.com that resolves, if you look at it from within the VM, it resolves to a private IP, and then if we resolve it from outside, it resolves to a public IP. So before we attach it to Foundry, let's just do a local test. In other words, let's just test it first with public, and then we will test it with private. And remember that the reason we are not using ngrok over here and using certificates is because with ngrok you cannot publish it privately. Okay, so that's the reason why we're not using ngrok in this demo. So here we have, we'll fire up npx just to check it out, and then we will associate it with mcp.penguintrails.com, which resolves to this VM's IP and an MCP, which is this VM. Okay, so here we are on that MCP inspector. We'll go mcp.penguintrails.com. Again, we are doing it externally. Now let's connect, and we can connect with HTTPS tools, list tools. This tools will look familiar, and then we'll google.com and we'll run the test. So it's working externally. Right, we got the ping. So it's working externally. I think you want to call out anything, Jacob, or Gabe, before we go and attach it with our Foundry agent. Looks like it's working.
Good. Yeah, public MCP servers, similar to before.
Yeah, and so we're just setting it up for our private connection now. So let's jump back into the portal. Here we will again be doing everything from the Bastion host. So here we are on the Bastion host, and so let me go to, what is it, the build here, models, or sorry, agents, and we'll associate it with our network assistant agent. And we'll modify the instructions, but for now, let's go ahead and add the MCP server. keep me honest here. So we have to go to custom here, right?
Yes.
MCP create. Okay, so we'll call this demo MCP server demo.
Also,
Right.
while
Yeah.
you're working on this, call out that we do support a variety of authentication methods now, including user pass-through, OAuth, and so on and so forth. I don't know if is your private one authenticated? It's unauthenticated.
Unauthenticated
Right.
for now. Yeah. So, and we will use the same endpoint as the one we used here.
Yeah,
Okay.
configuring this as a tool allows you to, if you have any authentication details like a key or so on, it keeps it. It's a safe place to put it in the connection.
Got it. So let's go ahead and hit connect. And there now we have added it. So I can't remember, do we need to modify the instructions?
You might want to tell it to use the MCP server connection, or tell it that
Yeah,
it has
so
a tool named demo private MCP.
yeah, so let's take a look at it. I think let me just let me bring this here. We'll copy paste it here. So it says if the user says ping, so this is for the function app, and do we? Yeah, so we'll call it demo private. What did we call it?
Demo private MCP server.
Okay, so that's all I have to modify here then. So we'll say, I think I named it slightly differently, so we'll just call this demo private. Okay, so we don't have the ping pong, the function isn't integrated yet, so we'll save it and do pinggoogle.com. The fact that it attached it over here is a good sign. The DNS and everything I think is working.
I agree.
There it is calling our tool, and we can
Right. So yeah, something we did not have in the classic Foundry and the previous iteration with MCP tools was an approval flow. Tool calls by default require approval in most cases. Maybe all cases
MCP
by default.
especially.
Yeah.
MCP tools especially will need that approval.
Right. So you have the option to approve the tool call on a one-off basis, or always for this tool, or always for all tools. And that can be configured in the SDK as well when you're creating the MCP tool connection.
Yes.
awesome,
there we go.
and that it's working.
One thing also, Nahali, when we
Yeah.
attach the tool, the DNS won't be validated. That is like a configuration portion. When you actually call and prompt the agent, then we would make a request to the server, right? And that's when you may see an issue with DNS resolution, right? So it's good. It is a good sign that when you add the tool here, that
I
it
see.
is likely to work, but it does not 100% guarantee that everything is correctly set up. Obviously for us, we validated all that DNS before and correctly configured, so.
That's a good point. Let's just double check the penguintrails.com or share that configuration and the the VNET links. So we did indeed link it to the hub VNet here. That's the hub VNet that we deployed. So coming back to the drawing board, it's linked to this, and then the DNS for this spoke is pointing to this DNS server. So it's working by the virtue of this spoke having this DNS server, right? So let's share that as well. So virtual networks. So this is the spoke VNet. There it is. So spoke VNet has a DNS server that's pointing to the 10.0.1.4. And we did validate that from within the VM, it was resolving to this private IP. So that means that everything within this VNet is resolving correctly by the virtue of this, the DNS server. All right. Anything else on? Let's go back to our jump box. Did you want to take a quick look at the logs then? The demo private MCP server.
Yeah, we can do that.
Looks pretty good. You can see a little bit of the tool output here, and what it did, and then how it synthesized into the message on the next one. So
Yeah,
looking
so that's
looking clean so far.
Perfect. So now I believe we're ready to make our function app. If you remember from part 1, we had 2 functions, and this is an interesting one. This gives us a lot of the API header information that will be interesting for this private demo. So if you're ready, we could go to this one now. We'll project this function app as a private endpoint, and then we'll connect it.
Let's do it.
All right, so here I am in the function app. Let's see, networking, and there's 0 private endpoints configured. And so what we'll do is first we'll disable public access. And we'll enable private endpoints. So we'll create we'll project it in the Foundry spoke, and you already have SNet private endpoint subnet, right? So we'll call it integrate with a DNS zone. Yes.
Yes, let's do that. Don't believe we have a zone already. So that should create a new private DNS zone as well, unless you already had one, Nahali?
Yeah, so let's double check. Only thing is, I think if we had done manual instead of express, it would have given us more options,
Yes.
but no worries. Let's go and look at private DNS zones.
New notebook file. Yeah, I don't see it. So let's click on the IP. Should be there. And under settings, DNS, we can see
Azure
Yeah.
websites, yeah.
Azure,
Azure,
okay.
yeah. So let's refresh here. Yeah, so here we'll just validate that it's linked to our spokes, which it is. So we should be ready to hit it privately then, now that it's also
The
anything
DNS
else?
server is on the hub.
Okay.
Shouldn't we link it to the hub as well?
Actually, that's a very good point. Yes. So this is linked to the spoke. So let's is this the right one?
Yes, that's the one.
And maybe we can validate this function app from the VM. At least we should be able to validate it from the VM. Yeah, it works. VM is resolving to private IP.
Perfect.
And so I think we're ready to integrate it with our edit as a tool.
Yeah, let's do it.
So, and here, how did we do this in our, pause here for a second.
We can add a name. We'll need to add the OpenAPI schema and modify the URL to the new function URL.
The function is still the same, right? So that's why I was just going to copy I was just going to copy it from our first Foundry, if you know what I mean.
Yeah.
So it would just be very easy. So we know exactly what we work. So what we'll do is we'll go to our public Foundry. Let me get it ready. I didn't have it ready. Yeah, so what we'll do is we'll just grab it from here and we'll just copy paste it to the other side. Okay, so let's do that. So here, what we can do, Gabe, is let's copy it from our the one we used in our public networking, because the function app is the same. It's just that we disabled public networking. So let's go to this Foundry. Make sense?
That does make perfect sense.
So see, yeah, so it's still 28512. So we'll just say Control A, Control C, and we'll paste the schema here. And we'll also get the names. And we'll paste it here. And we disabled public access, so it shouldn't be going over public anyway. So that's our first one. And then let's grab the next one, which is the ping one. And since we copied the instructions from the public one, let's just validate that it still says, yeah, tool function and tool API headers. So they all match. Okay, so let's go ahead and save this. All right, so here we are in our network assistant agent. We now have two of the tools that are calling the functions. And then here we validated that it is indeed calling the private IP for this function. So ready to give it a spin?
Yeah, let's give it a try.
All right, so if we say ping here,
Okay, it's running. Awesome.
yay.
We got bonk. We see the OpenAPI call as well, which is great.
And this is the one, right?
You can see OpenAPI call here. Yeah, and it fetches, it runs function app returns a response, and you can see here the output.
And also if we go to the traces, we can see the FQDN.
You should be able to see the function calls, yes, if you click on traces. Should pull up the conversation here. Yeah. Click on responses. Yes. Perfect. There it goes. It loaded. Click on that first conversation. That should be the last one. You'll see that first list of tools. It calls the tool function ping right here, and it has all of the details. From here, since you know what the function being called is, right, or rather the tool being called is the function app, you can then go to the actual tool definition and look at on the OpenAPI spec what is the FQDN being called for this tool. On
Got
the
it.
traces, you'll see the specific details on tool logs. On the on the tool, on the OpenAPI spec is where you have defined the specific FQDN you want to call.
Got it. So in the same place where you could, in the assistant here,
Mhm.
you can just grab it from.
Ping function and then edit, should be
Yeah,
able to see the server you defined. Yep.
got it.
Cool.
Yeah, looks like I lost my ping. Let's kick it off again and let's get the give me the API headers. And this is so that we can see the source IP of the container app.
Perfect. Yes, you can see here on the X client IP 10.1.1.121, that is from the agent's subnet being called. So yeah,
It's
you can
very
see
good. That's the
the stuff.
client IP and the XFF headers. And if I say give me full API headers, I believe it also lists that under the hood it's running. It gives the
You'll
container,
see
the
a lot more
container
details in the container app. Exactly.
and the K as namespace, much more detail. And Gabe, this should match what we see in the firewall logs as well, right? So in other words, if we go to the firewall and the logs, that should match that as well.
Right. If you go back to that latest call, we can take a look at the correct IP. Scroll up. Yeah, it's that 10.1.
1.121, right? So there should be some calls in this logs. We can take a quick peek.
Let's run that firewall log data.
Yeah,
Yep,
121. There it is.
10.1.121. So you
Perfect.
can see exactly the source of the calls are from the agent subnet where VNET injection is happening.
Very nice. All right, so that completes our demo for these two flows. First, we showed you how to talk to the private MCP server, and then we projected the private endpoint for the function app and showed you this second flow. They're both, again, working using the private IPs, and we disabled the public access to the PaaS service. Anything else, Gabe, or are we good?
No, I think that's great. Thank you, Nahali, for opportunity to be part of these series, and always good and happy to share our knowledge and content.
Yeah, of
with
course.
everybody.
Happy to have you here. And, this is a great enhancement from our previous sessions where we didn't have all of these functionality. So this is more
Definitely.
complete now. And all right. Thanks everyone for watching, and we will see you in the next video.
Thank you.